this 9 paper we present Spire Muse, a virtual musical partner for creative brainstorming. The musical agent utilizes corpora of solo instrumental performances encoded as self-organized maps, and outputs slices of the corpora as concatenated, remodeled audio sequences. The name Spire Muse is inspired by the notion of growing ideas from a spire. It could be a phrase, a sound object, a rhythmical pattern. Improvisation is like a cultivator for such basic themes. They grow into something more. Research shows that musicians alternating between pulling together and pushing apart is an important dynamic that moves an improvisation forward. We place these strategies on a continuum ranging from converging to diverging. To simulate such dynamics, Spire Muse is designed to engage in different interactive behaviors. Shadowing is a close following of the user's input. Mirroring is a stylistic reflection of the input, which could give rise to novelty. Coupling is a more autonomous mode driven mostly by the agent's internal generative routines. Negotiation is the meeting space where the musical agent trades decision-making with the user. We place shadowing, mirroring, and coupling along an axis ranging from reactive to proactive. Negotiation happens when the system switches between these behaviors, either autonomously or through manipulation by the user. Spire Muse's corpus training is based upon a modified version of the MASOM agent architecture and is implemented in Max. Modifications include extracting feature vectors that are better adapted to instrumental music. In particular, the inclusion of chroma features is important in this aspect. We also extract the tempo per song in the corpus, and a significant new inclusion is the detection of longer-term harmonic dynamics through chroma transition matrices, which count the number of significant transitions in the chroma features over 20 slice windows. The training starts by selecting a corpus folder. First, all of the audio is segmented into slices based on onset detection. Each audio slice is then labeled with a feature vector, in our case, containing 55 features. The self-organizing map creates a two-dimensional latent space through learning the internal relations between all of the feature vectors in the corpus. Each node in the map represents approximations of a varying number of input vectors. Every audio slice is then assigned to a node based on the best matching unit function. Hence, similar slices are clustered together at these nodes. Finally, each song in the corpus is encoded as a sequence of SOM nodes. In runtime, these sequences can be used as models for the factor oracle algorithm, which uses the SOM nodes to create new sequences in the same style as its source. Shadowing mode is the baseline behavior of the musical agent. In this mode, the agent responds reactively and outputs the closest matching audio slice in the corpus for each onset registered in the input. In mirroring mode, the agent listens to longer phrases and attempts to respond with similar phrases. It builds a list of closest SOM matches based on audio slices from the input stream. A KD tree algorithm finds the closest matching SOM subsequence among the list of songs encoded as SOM sequences. A factor oracle of the song containing the matching subsequences is initiated. In coupling mode, the user is coupled to a factor oracle which plays back continuously. The agent listens to the user and attempts to align with the input by intermittently loading new factor oracles from other songs in the corpus, or by jumping to new states within the same factor oracle. The agent's choices of songs to load into the factor oracle is based on tempo and chroma transition matrix matching. The negotiating interface functions as a counterweight to the agent's automated behaviors. Functions include forcing it back to its previous modes, pausing it, or changing its state. This version of Spire Muse is a proof of concept. An extensive user study is scheduled for June 2021.